Okay. Yeah. Okay. Hello, everyone. My name is Onaniyi Taofeek. I am a game developer, Godot game developer. I have been making game for the past 4 years. I I am a native of Ogunwota side, Nigeria, and yeah, today I will be talking about introduction to Godot engine, how you can use Godot engine to make a game, what is Godot engine, what is the importance of Godot engine, and how like like how can you use it. That is what I'll be talking about. So for the first lesson, for the first class, for the first session, I'll be talking about the 2D parts of the engine. Like we'll be talking about the 2D part of the engine. But before that, I know that they said that everybody should get the engine, but for those that don't have it, I will show you how to get it since it's just 80 MB. So I'll show you how to download it and how to install it just for some showcase. So let's begin. Okay. Okay. So to get to the engine, you just have to search Godot's engine to get to the website. The first link you got will link you directly to the website. So this Godot engine. So for a quick introduction, Godot engine is a open source game engine. And what's a game engine? A game engine is an application mostly on PC that is used to develop game games. But sometimes people use them for other things. Like I've seen people use this for virtual store for different kind of things, like different things. So Godot can be as Godot as a game engine can be used for all those things. So there are many type of engines. We have Unity, we have Unreal, we have G Develop. There are a lot of game engine. But what make Godot like have an edge over them is first I would say the size. But as we know in Nigeria here, we in my country, Nigeria, we don't really have much like data. Data is very expensive. So getting a game engine for at its low size is actually very great. For example, Unity. I would say Unity is almost 1.6 gig. Unreal is a lot more than that. Like I can say it's a lot more than that. But Godot is just 30 MB in size. So that is one thing the engine that's one thing that is very nice in the engine. Like, yeah, the size is also nice. Another thing that is good in the engine is Godot's open source. I mean, it is built by the community, by the people, just you like you and me, like just people coming together and building it. So it is not controlled by a corporation. So you can come into the engine, change some things, use it for your own list, and nobody is going to be chasing you around like for sue and suing you and stuff like that. It's completely free. So to download the engine, you just go to the home page. You are going to be using Godot 3.5. You click on download and that'll take you here. You download the version you want, 32 bits or 64 bits. And yeah, we are not going to be using C sharp in this tutorial. We are going to be using GD scripts. GD script is a programming language, like let's say scripting language that Godot use, like a built-in scripting language that comes with Godot. It's almost like integration of Godot and Lua, like it's an integration of Godot and Lua. So you bring the two, it's like it look almost like Python. If you have experience with Python, then it will look familiar, but it's not completely Python. Not so that you will not fall into like believing that it's Python. Yeah, it is different. So to download, just click on download and then it will then download. So I have it here already. So let me just close mine. I don't want to. So once you've downloaded it, like you have a folder like this, something like this, just open it. via zip. Yeah, as you can see, close. You open it via zip, like something like this. Open it via zip, and then you will drag like the engine out. Yeah, where is it? Also, so you drag it out, and then you have it like this. You have something like this on your screen. So that's how you install it. Like display, and it's no need for long term installation. Just download the zip file, drag it out, and then you have Godot. You have, yeah, coming. Sorry. Then you have Godot on your screen. Like, yeah, you have Godot on your screen. So next, the plan is now we want to like open the project. Next plan is to talk about the hierarchy, like how the layout of the game engine is. What's the 2D part, the 3D part. We're not going to talk about 3D part. I'm just going to talk about like the layout and stuff, how the layout look like, and then we'll start by trying to build a small project. Yeah, small project, just a project about the fixes or something like that. Yeah, just talk. I was going to talk about the fixes part of the engine currently. So to do that, you click on the project. Yeah, so we have a lot of project here, but yours will be empty. So you have a lot of empty project, just an empty space here, and then to create a new project, you add a new project. You give it a name. Just say sample. Just a sample for my sample. Yeah. So build a new project, and then you click on create folder. And for the renderer, we have OpenGLSL 3.0 and we have OpenGLSL 2.0. Like there's a difference between these two. If you want to create an high-end game, that it is not going to be for like mobile, except you don't want it to support some mobile phone. I think from 8.0 up. If you don't want it, if you just want it to be like high end and you just want to limit the amount of, it's going to limit the amount of phones that can play it, because it 3.0 can only play from phone from 8.0, Android 8.0 to Android 10. Yeah, from 8.0 upward. But if you change this to OpenGL 2.0, you can make any type of game with it and you won't have any compatibility error. Although the project will be low quality. So, but currently, I'll just put it as high quality. With this, not really, we're not going to release this project. So, click on create and edit, and then this will create a project for you to show a good icon. Just drag it, yeah, yeah. So, it could be something like this. The This is how your project will look like after it has been loaded. So it's an empty project with, here is where you add like your hierarchy. This place is your file system where it contains all files in your project. This is where it store like the node properties, where like properties of all these nodes. Godot make use of a node system, so everything is added as a node. Node. Like everything's added as a node. So yeah, so this Angular has a lot of node, as you can see, like there is a lot, like a lot of them, and there's a lot spatial, like a lot of them. You have canvas item, you have control node, and we have like a normal. Everything in this is used for 3D, 2D. Like anything in in this new 2D are most 2D assets, like physical 2D physical assets that can be placed on the screen in the 2D in the 2D world. Anything in a spatial node, all these things are used for 3D. Like if I make a 3D project, then you are going to be using a lot of stuff in this parts. And if you are making something that has to do with UI, like your UI, then this part is contain like the label, the panel, the video player, like all those things that has to do with your UI. That this is where you are going to find it. Like there is a lot of containers, like a lot of boss container everything. You find everything here. So yeah. So we are going to start currently. What we are going to do now is just a simple widget where we have a character, we have a platform, like we have something like this. Let me just draw it. Paints. Let me just draw it. Paints. Yeah. Yeah. So this is something we are going to do. Where's my pen? Yeah. Okay. Okay. So we we are going to like have character. Yeah, I'm bad at drawing. So sorry. Yeah. Okay. I think that is okay. So yeah, we're going to have a platform. We are going to have a character that we can move around. A character that can move around. So this is an introduction show. I'll just be showing you all nodes that can do this kind of thing and how they do it. And then you can choose the one you want to use. Like we are just going to have it for this learning. If we have more time, then we can continue and do more things. But currently, what I'm going to do is just have a character stand and then move it around. Like we can move it using a button left or right. I'm going to explain like the basic around it, like the knowledge, the idea behind it, and everything. So if you want to make something that has to do with moving a character around, you can be able to do it easily on your own, even without anything. I just want to like, although this is an hour class, I want to focus on something that I know that you're going to use later in future. I might not create the complete game, but like, focus on something that if you want to make your own game, you'll be able to work on it, to use that kind of knowledge to make your own game. So I'm going to explain it in depth, like what every line does, what everything does, and what everybody does. So for this kind of thing, if you are making this kind of thing, yeah, let me just drop it here. We are making this type of thing. I mean this kind of thing. So to for this kind of thing, we need bodies. Godot has like bodies. It has like in 2D form, it has bodies. Just go like this, yeah. You have physical bodies. We are going to use physics bodies. Yeah, we're going to be using this physics body. Godot has like three physics body. It has a kinematic body 2D. It has a rigid body 2D, and it has a static body 2D. Like for let us start with the static body 2D as its name, like as its name is a static body. Static meaning that it cannot move. You will be having an idea for that. We use something like static body for walls, floors, a place like a certain place, like all the surroundings, like floors, anywhere the player cannot walk on. We use static body for them. So if we want to draw a floor for a player, then we use a static body. Just for an example, this is how it looks if you want to have a static body. Let us go back to our 2D view. Let's save this. Let's save this as a normal. First, you have a normal node. If you want to start a node, you have a normal node. This node will be our parent. Like it will be the base node for that complete scene. A like a level, like something like this, a level, let me just call it a level, is known as a complete scene. Like this is a scene. Like once you save it, it's a scene. So you can have many scenes and then you can change into them. But every level is a scene. Every level is a scene. Different, you can save and paste a new scene, save and paste new scene, then save new scene. So in this, let us name is our level. Let's name it our level one. Let's see that level one. So in level one is our scene. So now we want to add the floor, just like as we are planning to do, just a player that is going to move. We are going to have something like a floor here. Player is going to move forward and back here, something like this. So to add something like that, you first add the static body. This static body. Then you add like the sprites. Sprite is sprite is the image that is used for that wall. An image that showcase that wall. Like let me just open another project and just showcase the wall. Open another project and just showcase something like how that wall is, something like that wall. Because we are still going to work on this. I think tomorrow, if we have like sometimes I created certain projects that we can use. So yeah. So something like this. Yeah, there's a comment. Yeah, okay, sorry, I missed that. So yeah, so this is the something this is like a wall, like you guys can see. Yeah. So all these parts are done with a static body and then the sprites inside. So the sprite is the image to showcase to the player, to the user, the person that is playing the game, that this thing like there is a wall here. So now let us play something like that. We are going to use this icon for our wall. We're just going to drag it down. We're going to drag it down like somewhere in the middle, then expand it. Yeah, something like this, just for the wall. We can change it. We can this part, as I said before, this contain the property of this node. Like as you can see, it changes. Like if it's static body, it contains like what is the linear velocity, what is the constant angular velocity. If you have knowledge of physics, yeah, this thing is going to help you in game development. Like if you are at least when you are making physics, when you are making yeah physics based game, this space game, then your physics knowledge will help you because in this place you are going to develop your own physics projectile and all those stuff. Those equations are going to help you. But if you don't have knowledge of physics, it's still okay. You can just search them online, see how they work, and then you just apply them into this. So yeah. So our static body, this it has a sprite. We can change the color. This is the property of this sprite. The sprite is like an image, as I explained before. The sprite is like an image to showcase what that static body look like when the player is playing it. So it does not be like people have different image for different type of things. So yeah, to do that, let me so the element of property there is center. This one show whether the image is centered or not. That's offset to show whether we can use it to offset the image. Yeah, as you can see, the image is gone. We can use it to offset the image to offset how the image will look. There is flip to flip the image left and right, left or right, like flip it, and there is flip H to flip it in the horizontal axis. There is flip V to flip it in the vertical axis, as you can see. There is animation that is used for animation. If you are using a sprite sheet, that's we are not. If we have time, we are going to talk about those things later because those are advanced stuff. There is region that's also for later too, if we have the time. So, and also we have transform. Transform is used to store the position of our sprite. Everything here, just imagine everything here is a graph. Like everything here is a graph. The y-axis and the x-axis. Just for just one thing that is different here is that y-axis of Godot is flipped. So our normally our y-axis, if I'm correct, is positive when you are going up and it's negative when you are going down. Our x-axis is positive when you are going left, it's negative when you are going right. When you are going left, it's negative when you are going right, it's positive. Yeah. But in this place, our x-axis is negative when you are going left. Yeah. If when you are going right, it's positive. But when you are going down, it's positive. When you are going up, it's negative. I hope that is like it's flipped here. I don't know why they flip it, but it is flipped here. Like but it is still almost like placing something in a graph. Like place something in the graph. So what we want to do now is in the property, we just want to change this modulation. This modulation is the color of this so that it turns to black. So yeah, so it look like this. As you can see, everything look positive, everything looks solid. So currently we are just making a wall. So currently we are just making a wall. Another thing that you need to add, as you can see, there is an error. Like it's telling you that there is an error in this. Like it's like the node has no shape. Oh, if you go back like to the past or something, we remember like while we are kids, the thought that matter is anything that have shape and occupy space. So currently, this body, this wall that you make does not have a shape. So it's not a matter. So this thing is complaining that it does not have a shape. Unlike like normal human being, you have to if you have to eat something like matter to make something a matter, like something that can interact, interact with, it has to have a mass. So we have to add another node here to add the mass. And the name of that node is called collision shape. We have collision polygon and we have collision shape. But we are just going to talk about collision shape currently. Collision shape is what we use to add shape to our wall or player or anything so that they can be with they can interact with other things in the level, like the other stuff. Like if the wall player can land on it, if it does not have a collision shape, player cannot land on it because that wall does not have a matter. The wall is intangible. It's like a ghost. It's like an illusion. So if you don't add the collision to it, the wall is just an illusion that cannot be interacted with. So once you add the collision shape, then it becomes something that you can be interacted with. So yeah. So in this, you add the collision shape, and then we have to expand collision shape to fit the size of our sprite, like so that the shape will be the shape of our sprite. So that is so that to make sure that, yeah, as we said, for matter is anything that have weight and occupy space. Yeah. So this now currently our wall is complete. Now we have a wall. We have a floor, like we have a floor that our player can land on and walk. So we are going to show different type of like walls and different type of bodies, how all those bodies interact with this wall. So first thing we are going to show is a rigid body. A rigid body is, let's just say, like you don't have to code the faces yourself. It has been coded already. You just have to change like the variables and everything will be working. Kinematic body is different because you have to code the faces yourself. You have to add the faces, you have to add the fiction, you have to add everything yourself. You have to code everything by yourself. Although I like using kinematic body better because if I code my physics myself, I'll have more control on how everything will interact, how everything works in my games. But for just to showcase, I will showcase how both bodies work. So first we are going to add, make sure you click on the level before you add this. We don't want it to be under, we don't want it to be in this static body. We want it to be outside the static body and just be outside like this. Let us name this wall. So yeah, let's add this. We call it our static body. No, not static. Yeah, so sorry. Rigid body, rigid body 2D. So rigid body 2D. Just call it ball because we are going to make. Let's also call it ball. We're going to make something like a ball. Yeah. So this is it. So we are just going to follow the same step as before. This is a body. We give it a sprite for the illusion to be visible. We give it a sprite. Yeah, give it a sprite. Now the sprite, we add this icon. We can, if you add different type of icon, you can add it. But currently, because we just only have this icon, so yeah, we're going to be using this guy for now. So we had this guy. So now we want to play around with stuff. We want to add our collision shape. So this will not be just be static. If you save this, let's just save this here. Let's save it. You save it and run it, nothing will happen because the ball is just going to fall out of this thing, like the wall, like everything is just going to fall out because the ball does not have a, a shape. So like a matter is the ball is not a matter yet. So now we add the collision shape into it. Collision shape into it. We resize it. We add it. We make it a rectangle. Let us say make the rectangle. And yeah, now it's going to drop and it's going to stay. As you can see now, everything is interacting. Like you can see, drop and stays. That is how like you make bodies that interact with each other. Now the floor has a shape, and the ball and the ball also have a shape. So another thing, one thing, let us now go to the property of the ball. There is a lot of things there. We can change it to mode from rigid to static to character to kinematic. Let's say static, you can also use like a rigid body, turn to a static body, and then like to turn to a wall, as you say, as a static body up there. To the rigid body was auto act like a wall. But we don't want to make that, we just want to make it a character. If we make it the character, like it will, like instead of bouncing and just rotating the sprite and everything, it will be static. The sprite will not be checking with the rotation, and everything will be kinematic. You have to code the faces. So yeah, it has mass. As you can see, it has mass, it has weight, it has a gravity scale. If I increase this gravity scale, it is going to drop faster. It's as if it's in the sun. Like the gravity is a lot higher. If I reduce it, it will be float. It will look floaty. I reduce it to look floaty. Let me that is too much. That is negative. Yeah, I think that's too much. 0.1. Negative gravity is going to be up, so I don't want negative. So yeah, as you can see now, it's just falling gradually, gradually, gradually. The gravity is almost as if it's in the moon. And just for you to know, all this is like a simulation. Is using the gravity is using like S gravity 9.8, 10.0. So you can apply real life equations. Like you can simulate real life stuff about gravity and stuff using this, and it's going to work because every code and everything that's working here is almost the same thing as real life. So yeah, you have, don't know what this guy does. Sorry, I don't use this guy. I don't use this node too much. So this is for collision detector to detect whether there is collision, continuous collision. You don't need that. This one is to report if it's touching something like contact. If it's touching something, to report back. Tell us which. This one is to say if it's sleeping. Like if it's sleeping, if it's not moving, then to stop the force and everything will just be sleeping. So this linear is where you apply force. Like you apply force. If I apply like 30, 40 here, like I apply force to the left, something like this. Let me just draw it. Let me just do it. Let me showcase it. Yeah, why is my drawing? Why is my, oh yeah, I lost it. Okay, okay. Yeah, let's. So yeah, let us say we have our character. Let's see, we have our character. Oh, yeah. So yeah, okay. One, we have a box. Our ball is here. So normally it's going to drop because of gravity. Gravity is applying on it. We have dropping normally because gravity. So in that linear velocity, if you apply like a linear velocity of zero of linear velocity of x, linear velocity of x, let's say linear velocity of x 40, comma 0. This will apply a force on the 40, a force of 40, like what is unit of force? I'm not really teaching physics, so let's not do that. So yeah, if you apply a force of 40 to the right side, like yeah, the force will be pushing our player like this, and going down. So it's becoming somewhere like this, I believe. Although it should be coming from here like this. This is applying this one is applying 0, comma 10. Oh, yeah, I'm using this thing. So this one we're applying 0, comma 10 as graffiti. Graffiti is applying like something here. Graffiti is coming down from here. I was applying 10, comma 0. And this one is applying, no, this one is 0, comma 10. Oh, sorry, 0, comma 10. Why am I making mistake? So yeah, something like this. So total force would be like something close to 40 to 10. So two different forces acting together and something like. So if we go back to our ball, we go back to our ball, and then we apply inner force of 40 here. If we want it, it's going to, as you can see, like you see, like there is slight movement, like a slight force acting on it to that side. So that's linear velocity. Linear velocity according to, yeah, let's just search it. Let's just search it. Linear velocity. Alright. Linear velocity. Linear velocity, the rate change of displacement in respect to time when an object moves in a straight line. So it's just the rate of change of displacement in respect to time. So we apply linear velocity of 40. So we push that in 40 to the left till, yeah, 40, 40, 40, 40, 40 until it stop. So that is linear velocity. Damping is how the force is lost, like how much time is the force that we apply is lost. I think I'm correct now. Yeah, so it's damp damping is damp is how the force we apply is going to be loose based on friction and stuff, like how how much friction the air surrounding us. So, and the angular velocity is how the body rotates. I think that is mostly how the body rotates. Mostly how the body rotates. Mostly how the body rotates. From what I believe, mostly how the body rotates. Yeah, it's mostly how the body rotates. Like that is the angular velocity. And we have applied force. Like this is the force, like normal instead of linear force, applied force, like a constant force that is applied at a constant rate. Let's just say 50. The player is going to move in at 50, 50. It's going to be pushing to the left continuously, based on my knowledge. Yeah, as you can see, the player is going to move it with left. It stops on the floor. Mm, mhm. So yeah, that is how everything is going. So there is one thing that I'm still looking for. Where is it? Where's bounce? Yeah, this and there's one thing we can add to. We can add the physics material, and in that physics material, we can add friction. We can add roughness. I can add bounce. Bounce is how all these ball in big baker games are done. Like they are rigid body balls that they got a linear force applied to them when that's like, yeah, like let me just draw it. So I just draw how that thing looks. So let us see, delete this, delete. So let us say we have a force applied here. We have, let me just write like this. Why am I using this? We have the ball and we have a ball on it. The ball is going to be like 0, 0 currently. 0, 0 currently. So then we have that line that always shows at the beginning of all this big backup game that will be showing where the force will be going. So this will tell us, you should help you like set up where the ball is going. Then once you now click, if you click like somewhere like this, it will calculate that direction based on your ball position, and then get like a force, like a direction. Like if it is can I type control Z? Yeah, can I type? I can't type. So if the force here is now like, it's not like the direction and the force, everything is calculated, is now 1 to 0, then they will now multiply like the speed of the ball to it. So now the force will now be applied to the ball using our applied force. This our applied force. The force will be applied to the ball. So the ball will now move in that direction, and then we leave every the remaining part of it. The bounce will be set to like one, and friction will be set to zero. So no force is lost. Friction make us lose energy. Friction is what make like when you once you shoot a bullet, it's going to land. If a plane like if you throw a ball on the if you throw a ball, it is going to like lose force. And although that is also done by gravity, but if you roll a ball on the ground, it's going to lose force as it's going, and then it's going to reach a spot where it's going to stop. That's what friction does. So if we move the friction completely from here, and then we increase the bounce to the highest, we are going to have something like this. Bam! You see, no friction, so no force is getting lost. So yeah, although the reason why this ball is flowing down is because of gravity, it's not because of friction. Because gravity, if you have it going by the left side, just keep going. So that is about rigid body. I have talked a lot about rigid body. Waste a lot of time because of rigid body, but that is how I said I want to give in depth. So that's okay. So that's how rigid body works. They they take the sprites, they turn it, they just like they have everything already coded. So you just have to play with this option in the code, and then everything will work. You have to play with this in code. You don't have to like code all these functions yourself. You just have to place them, and then it will work. So yeah, let us now talk about kinematic body. I have 15 minutes more. So I don't know whether it will be enough time to talk about the kinematic body, but yeah. So this is a kinematic body. These guys do not have any physics, like you can see. No physics added. You have to code them yourself. That one's going to take a lot of time. You have to code them yourself. So, but okay, I think I'll just do that tomorrow. So, just for now, I'll say like any questions on all those things I've added, you can add more balls. Just end it here for now. I don't want to push a lot of things because these guys, kinematic body are different beast on its own. So let me just copy and paste and apply different linear force 40 and paste. You can make this one graffiti. You can make this one mass higher. The more the mass, the more the graffiti. I think the more the force of gravity applied to a body, the more the mass, the more the yeah. I think so. I think so. And mass is multiplication of is weight is mass times gravity. So that is why once I change my mass, the weight also changes because yeah, our weight is affected by our mass. Our weight is calculated is just our mass times gravity. I'm giving physics class. I'm sorry for giving physics class. Uh, so yeah, let us change this one mass, and then we can just leave it. Let them play around, just bounce around and everything. So any question, please. Before I don't want to talk about the other part. Let me block this. So yeah, you can rotate. Should have talk about this later. I don't. So now, just questions. Mhm. Mhm. Mm. Why am I copying that? Okay, yeah. So now we have something like this. So this is all we did today. Just some bodies having zero friction, just passing around. Yeah. And the reason why this body is getting affected by this body is because this body weight is more than all these two. Like, let me just want it. The weight also, like, as real life, someone that is bigger, yeah, as you can see, it land on him and the force is not canceling each other. The weight is more. So yeah. Mm, yeah. So currently, that's how board games are done. Mostly just rigid body. Oh, modifying the mass won't let the ball fall faster. Let me see. Let us check. Let's see that theory. I think it will. I think it will. But let's see. Will it? Oh, why are they two balls inside each other? Yeah, that can be a problem. Let's see. Let's see. Let's see. Modifying the ball won't change the so this ball. Let's hide. So this ball has a mass of 1. This guy has a mass of 1. So this is the first example, the first place. Let's show how it land. This ball, as it land. Oh, yeah. Let me remove this guy. Let me move this guy to the left so it's not affecting our our experiment. So this is the ball. This ball, we are checking this ball. It's landing. That is the speed it land. It land at almost the same speed as this guy. Oh, yeah. We can even do that. So this ball is at the mass of 1 to 9.8. This ball is also at the same mass. I think they are the same property. So we are going to increase the mass of this ball to 9, and then let's see if it affects how it falls. Mostly, yeah, let's see. Yeah, the mass did not affect it. I think you are correct. I think you are correct. So changing the mass does not affect gravity. Is it when they fall at an higher side? So yeah. Oh yeah, you are right, Kelly. Changing the ball does not affect the fall speed. They still fall at the same. Changing the mass does not affect the fall speed. They still fall at the same speed. They still fall at the same speed. Okay. Let's put 3 of them here. Let me remove the linear force with the angular force. Remove the linear force. Linear force. Linear force. Yeah. So they should all fall at the same speed, even when they have different masses, although they have the same gravity applied to them. So yeah, yeah, you are right. Yeah, they are falling, but there is still some variation, but they are still falling at the same speed. Yeah, yeah, okay, okay. Changing the gravity scale. Yeah, changing the gravity scale will affect them. Surely, let's try. Let's see that soon. Change the gravity scale will affect them. We've already. I think let me just change that to 4 because a lot more gravity is going to push everything down too much. So yeah, change the gravity is going to affect them a lot more. Also make them lose the bounce energy a lot more faster. Yeah. So yeah, that is all about physics. Godot physics, like in the rigid body, that is a lot about Godot physics. So yeah, let's before we go, let us just do a recap of everything. Any question before I start the recap? Any question? So because I want to start the recap by 4:55, talk about everything I've talked about, and then I will try to give an assignment, maybe just play around, people just play around with the balls or something. Oh yeah, just I've like not really talk about how to change the sprite, so I'm not really so yeah. So now we are going to do a recap on what we did. So we first we talk about Godot, we talk about how important, like what make Godot different from other game engine, the size, the fact that it's open source, and yeah, and the fact that it's easier. Let's just say the coding is easier. It's not using C sharp, so the coding is easier to learn. If I start coding, you will also see that it's easier. We'll talk about coding tomorrow. So it's very, very easy to learn. The coding part is easy. Chef kiss. You, you will love it. So yeah. So and then we talked about making a player ball landing on the ground and everything. How to move the player left or right. We said we are going to do that, but sorry, I'm really sorry. I was not able to reach that stage. I apologize. Tomorrow I'll surely talk about how to code your own player, s- how to code your own player to move him around. So then we talked about mm, we talked then we talked about let me see. Then we talked about the static body, how they are used for making walls in the game. Like the static body 2D, how they are placed, how collision shape, how the collision shape how the collision shape is used as the matter, like to define the shape. Like if the collision shape is not there, then that means that body does not have a shape. Like it's matter, it's not a matter, and then it's just an illusion. Like anything does not have a matter that is just visible to us, that is not a matter, we call it an illusion. So it's just an illusion. So to make it solid, we have to add collision shape to a body. Like from the difference, let us just say, like in real life, in gaming view, difference between a ghost and a person is that one have a collision shape and the other does not have a collision shape. One have a collision shape that you can collide with, and the other does not have a collision shape, except the ghost is like, Akuma or this anime guys. They always turn off their collision shape sometimes. So yeah, and then we talked about rigid body, how rigid body works. Rigid body is a ball. Rigid body is mostly, I would say, mostly used for balls because most people like places that we want to look like the same thing as real life. We just use rigid body for it. Like you want it to be closer to real life, you use rigid body for it. But if you want to make your character is going to break a lot of laws of physics, so you won't be able to, you won't like using rigid body for them because yeah, you don't want your character to follow the law of physics in that game because people come into the game to break the law of physics, not to not to have fun with the law of physics. Yeah. So after we talk about that, what next? We talk about how the properties can be changed to get different kind of behavior, how the angular velocity work, how the linear velocity work, how the applied force work. So and then we talked about it just stimulates how everything will look like, even how the mass will work. So how the stuffs, everything in the game, how you can change everything, and yeah, that's all we talked about. So if you tomorrow I'm going to make sure I talk about how kinematic body work, and then we can talk about making. Tomorrow. I also send. I made this in a GitHub. I also send the link to the GitHub. I think cancel. So this is already uploaded on GitHub, on the open source GitHub. So this already uploaded on a GitHub open source. So and the asset, everything has been set. The level, everything has been set. Tomorrow we can try to make a kinematic body on here, like on a screen like this, on a screen like this. We will draw the level. I've made some this thing. Although I really want to talk about them, how to make them load. So I will talk about them, how to make them and stuff. But yeah, I really want to talk about how this works, how they work or stuff. But yeah, I don't know whether we will have the time to talk about that. 'Cause this is also another thing that we have to learn when you're making game. But yeah, but we are going to use this tomorrow. It is an asset. We have set everything, every enemy and stuff. So we are going to talk about how to make a player, and if we have time, we are going to talk about how to animate a player to walk around. I hope you come tomorrow and let's continue this knowledge part and have fun. Thank you.